The clock started before sunrise on November 4th, and the quiet was not empty. Amateur observers posted frames that looked colder than expected, a compact sapphire bloom wrapped around a charcoal spindle. ESA's tracking feed confirmed what the night sky had already whispered. The Jupiter Icy Moons Explorer had completed a close observation pass of the interstellar object 3I Atlas and was now turning its antenna toward Earth. A handful of lines in public logs hinted at a brightness rise that did not match dust release. An ESA spokesperson repeated careful phrases about preliminary telemetry and routine pipelines. Meanwhile, a familiar silence spread from places that usually speak, and the kind of silence that follows when a straightforward answer would only invite sharper questions. The puzzle formed in layers anyone could hold in their hands. If 3I Atlas is only ice and stone, then sunlight, angle, and spin should rule the light we see. If activity bloomed, then gas should scatter light in a soft halo, with grains drifting like powder in a slow blue storm. Yet early notes from observers and a few careful professionals spoke of a tight core, a disciplined glow, a color that stayed the same across changing angles. You could scroll recent threads and find the careful skepticism of working scientists side by side with the curiosity bake of skywatchers who simply know when something looks wrong. A well-known science communicator urged patience, and a Harvard voice asked for data, and between those two poles the air felt charged. Two paths, then, and they have been waiting for us for weeks. The first says the surface is being irradiated, that charged particles in sunlight wake up a crust and make it shine. That explanation is reasonable, almost comforting, and it keeps the story inside nature. The second path says the glow is not a symptom, it is an output, and that somewhere beneath the fractured skin of this long traveler lies a driver, a device, a thing built to push. It would not need to flash brighter than a city to disturb our sleep, only to keep its rhythm when geometry and distance should have made it fade. We are here to walk between those paths without raising our voice. Dreamy Stargazer exists to take a long breath, to open the window on nights like this, and to trace the shape of a mystery without forcing it into an answer. We will keep one hand on what is known and one hand on what is possible. We will move slowly through fresh logs, old papers, public statements, and private rumors, and we will keep you company while the world pretends to be certain. If you value calm, long-form work that treats wonder as a companion, consider settling in with us. Subscribe, so you can return to this room when the next piece of the sky turns strange. Like this video, if thoughtful pace helps you think, share it with a friend who enjoys questions that do not need to be solved in one night. In the comments, tell us what you see in the light curve, whether the color feels natural to your eye, and which path your intuition follows. We read with care, and your notes often send us toward the next drawer to open. Now, dim the lights, and let your attention narrow to a thin blue ring and the soft ticking of a spacecraft that has seen more black than any of us will in a lifetime. The close observation of 3I Atlas lasted minutes, yet everything important about it moves at the speed of trust. JUICE is an instrument platform that understands ice and magnetism and light. Its cameras and spectrometers do not care about rumor. They measure, they compress, they hand the truth to radios that speak in an alphabet of numbers. In Darmstadt, technicians sit at consoles under soft lamps and watch for patterns they have trained to recognize. When a rise in a specific band persists across exposures, when a phase angle change fails to soften a highlight, when a scatter plot tightens instead of blurring, a room like that gets very quiet. The first hours after downlink are always the same: a flood of packets, a first pass through automated routines, and then a pause while human eyes slow the stream and pick out the threads that matter. Here's one thread we can hold without stepping beyond our anchor points. If the irradiated crust model rules, then the glow should be diffuse, a mist, brightest where sunlight is strongest, ragged at the edges. The color should drift a little with angle and distance as different ices and grains speak at slightly different wavelengths. Instead, the early eyewitness language keeps returning to the same phrases: coherent, directional, aligned. That is not a verdict, it is a temperature. Coherence is a word that belongs to lasers and disciplined emitters, and directional is a word you use when a lighthouse sweeps a seam of light instead of spraying a fog. If the surface is a broken mirror of ice, it should sparkle. This looks like a beam. A single vivid image helps the mind stay balanced. Imagine a midnight harbor and a ship wrapped in tarps, moving without sound. In mist, floodlights would turn the air into milk. In our harbor, a single searchlight draws a knife edge across the water, a line that stays a line even when the ship turns. 3-Eye Atlas has that quality tonight. The glow does not bloom, it holds. Even if you reject the dramatic reading, the visual pushes you toward questions that are not gentle. What would make an interstellar body carry a light that behaves like a disciplined instrument, and how long has that discipline lasted? There are hard facts to keep within reach as the heartbeat of speculation climbs. The date is fixed, November 4th. The spacecraft is real and busy, a European mission that left Earth to study Jovian ice and now finds itself with an unplanned obligation. The tracking center is real, and the teams are competent, and the chain of custody for their data is usually clean. Nothing about that needs embellishment. The grounded speculation begins when you ask whether the instruments saw a spectrum that clusters around a narrow band with a steady ratio to reflected sunlight, and whether timestamps line up with a faint radio murmur near 1.5 gigahertz that some listeners have whispered about for days. It is responsible to ask, and it is responsible to admit that asking is not proving. Our imaginative leap stays small for now, small enough to carry without breaking the spell of plausibility. If the glow is an output, then a driver exists. Drivers do work. Work changes vectors. We would not need to see a dramatic arc to suspect guidance, only a cumulative gain that refuses to average away. Think of it as a steady day-by-day nudge on the order of a few hundred kilometers of extra speed each day, a gentle hand on a shoulder that still leaves fingerprints. With only a few hours of data, we cannot assign a number we can defend, but we can hold the shape of the idea and watch where the line leads. There is a question to leave on the nightstand as we end this first pass, and it is not whether large institutions ever choose silence. They do. The question is simpler and more unsettling. If a withheld image exists, and if a room full of careful people has already seen a pattern they do not want to name, what story are we being prepared to accept in the morning? The next section will test the safe path with patience. We will take the irradiated crust model at its strongest, and we will see whether it bends or breaks when placed beside the light we have just described. Two folders sit on the same desk. One is labeled natural, the other is labeled directed. The difference between them is not poetry. It is a checklist of signatures that any careful observer can test without raising their voice. The natural folder holds the irradiated crust model. It says that charged particles, ultraviolet light, and micrometeoroid hits wake up a fragile skin and make it glow. On a body like 3-Eye Atlas, that skin could be laced with simple ices, silicates, and carbon grains. When sunlight and plasma touch a surface like that, the response is messy and soft. Brightness spreads into a halo. Color drifts with angle as different grains sing at slightly different wavelengths. Polarization varies as microfacets scatter light in many directions. Thermal lag smooths the curve so that peaks arrive gently after the warmest moment. If gas is involved, the coma grows, the tail breathes, and the spectrum shows broad features from known volatiles rather than knife-thin lines. Above all, nothing about it should keep strict time. The directed folder holds what we will call the engine hypothesis. It does not require a roar or a cinematic plume. It asks for a disciplined output that survives rotation, distance, and geometry. The glow should stay tight. The spectrum should cluster in a narrow band with a stable ratio to reflected sunlight. The color should hold while phase angle changes, as if some emitter keeps control over the wavelength. Polarization should prefer a line instead of a cloud, which you would expect if a beam or lanced sheet of light leads the scene rather than a fog. Most telling of all, any measured radio murmur should rise and fall with the blue output, as if a metronome inside the source sets a pace that light simply follows. We anchor both folders to a few hard facts so the room stays calm. Hydrogen speaks at about 1.42 gigahertz. Natural masers in space whisper near 1.61 gigahertz when hydroxyl radicals amplify microwave light. Comets have shown that maser trick, but only in very specific conditions and usually tied to broad, messy outgassing. A faint beat near 1.44 gigahertz would not fall neatly into those known bins. It would sit nearby like a polite knock that does not match the house keys. That is not a verdict. It is a reason to keep listening. Now we sketch predictions the way a field notebook would. The irradiated crust model predicts diffuse scatter and a phase curve that relaxes with angle, like a soft lamp turned through a fog. The engine hypothesis predicts coherence, not in the strict laboratory sense, but in the everyday sense that the glow behaves as one piece. If rotation is fast, a natural crust will sparkle as facets take turns with the sun. A directed source will paint a seam that holds shape even as the body turns. If outgassing is the driver, then mass loss estimates and dust cross-section should align with brightness. If a driver is the driver, then brightness should stay high even with little or no visible gas, because the output is power, not spray. There's a thermal clue we can carry without dramatics. A sunlit crust warms and cools with time. Infrared brightness should lag the visual peak by a modest, regular amount. If the blue light is a thermal echo, that lag should be present and countable. If the blue light is an output, the lag could collapse or even invert because the emitter sets its own schedule. A small instrument team with a clean clock could compare timestamps across bands and learn more in one quiet hour than a month of argument will ever produce. Geometry offers another calm test. Natural scatter broadens as phase angle widens. Directed emission can stay sharp at larger angles if the beam is narrow. Imagine a lighthouse on a headland. In mist, floodlights turn the air into milk. A searchlight cuts a line that stays a line for miles away. If the glow around 3i Atlas is a searchlight, then frames taken at different phase angles should keep edges that refuse to fuzz out. If the glow is mist, those edges should surrender to the air. Energy accounting is where many imaginative leaps fall apart, so we keep ours small and sleep safe. A directed output does not need to be a rocket in the classic sense. A photonic thruster that pushes by throwing light can do work without ejecting mass. A narrow band emitter could focus most of its budget into a single color that our instruments are already watching. A very gentle acceleration on the order of 1 millimeter per second squared would add roughly 100 kilometers per day of speed. Over a week, that would produce a change you could see with patient stacking. We do not claim that number, we hold it in the hand as a scale to compare against whatever the downlink reveals. Control theory gives one more gentle clue. Natural systems tend to wander. Directed systems tend to hold. If the blue output is a device, micro variations should cluster around a set point, the way a thermostat keeps a room from drifting too far even as weather changes. If it is natural, the curve should drift with environmental inputs more freely. Analysts in quiet rooms look for that kind of behavior without needing to believe in anything dramatic. They plot variance. They scan for long intervals where the system refuses to stray. Those plots whisper before any press release speaks. We can score the two folders without pretending to close the case. The irradiated crust model earns points when we see diffuse halos, color drift with phase, broad spectral features from common ices, and a visible reservoir of gas that carries the light. The engine hypothesis earns points when we see a tight core, persistent hue across geometry, narrow spectral clusters that hold ratio, polarization that prefers a line over a cloud, and timing that correlates with a steady radio beat near the hydrogen neighborhood. Even a partial match on that second list forces hard questions, because natural explanations can cover one or two of those items, but not all at once, not for long. A vivid image keeps at our balance while numbers gather. Picture a surgeon's lamp in a dim theater, a single circle of blue that stays crisp on the same patch of skin even as the table tilts. In the balcony, a metronome clicks at a quiet pace that the lamp seems to obey without looking at it. You could build a natural story for one of those details. You could argue a lucky alignment or a short-lived jet. But if the circle stays crisp, and if the clicks keep time, the balcony starts to murmur. So we leave the desk with both folders open. We keep one hand on hydrogen at 1.42, hydroxyl near 1.61, and the calm truth that space is full of subtle amplifiers that sometimes fool patient people. We keep the other hand on a simple rule. Devices hold discipline longer than ice can. In the next chapter, we will take the safer folder at full strength. We will test the irradiated crust model under the best possible lighting, and we will let it carry the weight of the blue night for as long as it can bear. The first hint did not arrive with a stamp. It arrived as a pattern that survived compression, a narrow ridge and a spectrogram that should have blurred like chalk dust if the source were a frost halo. In the early hours after downlink, a screenshot moved quietly among trusted watchers, a thin bar of blue annotated with a note about calibration offset and dark current correction. The image carried no logo, only a time window, a band index, and a label that read Trial Stack 4. It looked ordinary until you noticed that the ridge held shape from frame to frame while the broader background breathed. The language in the accompanying note was the kind professionals use when they need to speak without committing. An operator referenced an emission cluster that immediately hedged by citing flare contamination and phase angle artifacts. Another line mentioned a coherence score, not in the strict interferometry sense, but as a simple measure of how well the blue band kept its outline compared to the red and near-infrared bands during the same minutes. A third line asked whether a cold pixel mask could be inflating the signal and proposed a reprocess with a different mask to see if the ridge would fade. We hold anchors so the mind does not drift. Juice carries cameras and spectrometers built for ice, rock, and fields. Spectrometers record light in shallow bins that reveal composition and temperature by shape. When a surface is irradiated, those shapes are broad and forgiving, more like hills than needles. When a device speaks, the shape narrows. The screenshot showed a central ridge at roughly the same wavelength across multiple frames, with shallow shoulders that rose and fell together as if a dimmer switch raised the whole structure at once. That is not a verdict. It is a reason to look twice. A second fragment surfaced on a separate channel, a text block that read like a draft for a shift handover. The author referenced a consolidated brightness estimate that refused to relax as the phase angle widened, then compared it to a control target to confirm the instrument was not drifting. There was a line about polarization that would be easy to misread. The writer did not claim linearly polarized light in the strict laboratory sense. They wrote that the preferred polarization orientation changed less than expected across frames, which is another way of saying the scene looked more like a line than a cloud. We keep the speculation grounded by laying out the catalog of known culprits. Plasma events can inject spurious signals. Glow from charged dust can mimic an edge for a few frames. A lucky jet can carve a straight seam for an hour. Compression can create bars and ladders if settings are wrong. Each of these possibilities must be crossed out with care. The handover drafted some of that work in plain language. It logged a plasma environment check using upstream solar wind forecasts and found conditions quiet. It documented a change in compression ratio and a full reprocess with an alternate pipeline. It noted that the ridge survived both changes within the stated noise limits. A vivid image keeps this from turning into a wall of qualifiers. Imagine a violinist warming up behind heavy curtains while the orchestra tunes. You cannot see the player, but at steady intervals, the same note surfaces above the hum, not louder, only present, like a bead of glass rising through water and catching the light each time. If the hall is random, that bead should wander. If a hand is on the string, it returns to the same place. The blue ridge in the screenshot felt like that returning bead, patient, precise, indifferent to small changes in the room. There are hard facts we can speak aloud without anxiety. The observation date is fixed. The mission profile is public. The pipeline steps are standard, from bias subtraction to flat fielding to radiometric calibration. A persistent narrow feature that holds ratio to reflected light across multiple rotations would be unusual in this context, but not beyond the reach of the instruments. The grounded speculation that follows is simple. If the ridge belongs to the object and not to the instrument, then we are looking at something that behaves more like a disciplined emitter than a soft halo of energized frost. Energy accounting keeps us honest. If the glow were driven by outgassing, mass loss estimates and dust cross-section should scale with brightness. Observers continue to report a tight core with little or no visible coma, which weakens the natural spray story. The imaginative leap we allow ourselves is small and contained. A narrow band emitter embedded in a fractured shell could radiate in the blue while spending much of its budget where our eyes do not look. The blue would be the telltale, the glint on the water, while the main work happens in microwave or near ultraviolet. If such an emitter is a driver rather than a lantern, it could couple light to motion without ejecting mass, which would explain stability without a plume. We balance that leap with the most stubborn question in instrument work. Could the ridge be a ghost? Ghosts happen when internal reflections or readout quirks draw false features that ride along with real ones. The handover draft shows a team trying to chase that question by rotating frames, swapping calibration files, and comparing to a control target with similar brightness and color. A ghost should shift when you flip the instrument frame or when you adjust a gain stage. In the few frames described, the ridge did not wander. That does not crown the engine hypothesis. It simply keeps the door open while the natural explanations thin out. There's a softer human thread woven through the drafts that deserves a moment. The language is tidy. The hedges are sincere. No one writes the word engine. No one writes artificial. They write aligned. They write persistent. They write coherent as a measure of tightness rather than as a claim about wave phase. That is how professionals signal that they see a shape without naming it. Outside the room, readers will add the names. Inside the room, a single noun can tilt a mission. The restraint is part caution and part culture, and it is the right shape for a night like this. So we close this chapter with one open question that belongs at the edge of the desk rather than at the center. If a disciplined Blue Ridge persists through the next calibration pass, and if a quiet timing plateau in the housekeeping stream stays married to it, what is the most boring explanation that still fits the data? If that explanation fails, the folder labeled Directed will no longer be a thought experiment. It will be the shortest path through the night, and the safest way to say the thing no one has written yet. A new section opens like a slow dawn over cold water. We set the safe story on the table with care, the irradiated crust that glows when sunlight and charged particles wake it. Then, with the same care, we begin to lean on it. We listen for creaks. We do not ask it to fail. We ask it to hold under the weight of the night we have just seen. Start with geometry, because geometry is gentle. A sunlit, energized skin should scatter like fog. As the phase angle widens from near zero toward a few tens of degrees, the halo should loosen and the edges should relax. Oppositional brightening near very small angles can spike and then fade, a quick flare that belongs to rough, granular surfaces. The frames we have so far do not behave like a fog. The core stays tight. The edge retains a hard line that resists the expected softening even as the viewing angle changes by several tens of degrees. That is not a verdict. It is a mismatch between what frost does and what this glow keeps doing. A natural crust can look sharp for a minute. It should not keep its knife for an hour. Color is next, because color forgets to lie. An irradiated surface built of mixed grains will let the hue wander with angle and time. A little more blue here, a little less there, like paint stirred by a lazy hand. Instead, the reported blue ratio holds within narrow bounds across rotations and phase swings. The cluster does not spread. For a cometary skin laced with common ices and silicates, you expect gentle drift. Here, the ratio behaves like a dial set by something that prefers constancy. Analysts usually describe that kind of behavior in quiet, clinical words. Stable, bounded, insensitive to geometry. Those are not words that rescue the crust. Polarization is the quiet test that often closes debates while the loud words keep fighting. Natural scatter from a rough, icy surface tends to show a polarization fraction that slides with angle and a preferred orientation that swivels as microfacets take turns. In early notes, the preferred orientation appears to change less than predicted, and the fraction holds closer to a line than to a cloud. No one is claiming laboratory-grade linear polarization. The point is subtler. When you map the vectors, they behave like threads pulled in the same direction. Frost, dust, and gas do not love that kind of discipline unless a jet is doing the pulling. If a jet is doing the pulling, you should see the jet. Thermal behavior gives us a clock, and clocks are calm. Surfaces warm and cool with lag. A crust that emits visible light by thermal and chemical processes should produce infrared peaks that arrive after the visual brightening by a small, regular delay. The first pass at the downlink hints that the blue output does not wait its turn. If there is a lag, it is not behaving like the familiar slow breath of a heated skin. There is a plausibly boring reason for that. If the blue output is not a thermal echo at all, if it is an output that sets its own schedule, the lag collapses. You see the rise when the device speaks, not when the surface warms. The crust story dislikes that schedule. Spectra are supposed to rescue us here. When surfaces are energized, they speak in broad features, hills more than needles, blended by grains and roughness. Natural masers do exist in space, and comets have been known to show narrow emissions near familiar microwave lines when conditions align. Those episodes live near hydroxyl, near 1.61 gigahertz, and hydrogen, near 1.42 gigahertz, and they usually ride with messy gas. The beat whispered in side channels sits near 1.44 gigahertz, a polite neighbor that does not share the house. More important than the exact number is the behavior. The reported radio murmur rises and falls with the blue light like a metronome paired with a lamp. Broad chemical glow does not keep that kind of time without a conductor. If the crust is our soloist, who is holding the baton? Energy budget is where the safe story usually wins, so we give it every advantage. If the blue brightness is powered by outgassing and sputtering, you need mass to move. Dust cross-section must scale with luminosity. Gas should reveal itself either as a soft coma or as a tail that breathes with rotation. Observers still describe a compact source that refuses to sprout the expected mist. You can appeal to invisible gas and very large grains that hide in the glare, but that rescues one test at the expense of three others. The crust asks for mercy that the scene will not grant. A glowing skin that keeps a hard edge, a constant hue, a stubborn polarization thread, and a clock that counts with a radio neighbor is a skin that no longer sounds like a skin. A single, vivid image keeps us from drowning in checklists. Picture a lighthouse on a winter headland, wrapped in freezing fog. If you switch on a bank of floodlights, the air turns to milk. The beam dissolves into a glow that has no edges. If you switch to a searchlight, you cut a blade across the dark water. The blade stays a blade as the tower turns, and the fog becomes an accessory rather than the author. The irradiated crust is the floodlight. What we are watching looks and acts like the searchlight. You can tell yourself the fog has learned discipline, or you can admit that a lamp designed to draw a line has been live all night. We keep 1 foot on hard ground even as the mood darkens. Natural processes can mimic order. A well-placed jet can draw a seam for a while. A plasma pocket can bias a detector. Compression can carve ladders. The team in the room has methodically poked at each of those traps. Geometry changes failed to blur the edge the way fog should blur. A compression change did not erase the ridge. A control target with similar brightness did not grow the same line when pushed through the same pipeline. The crust still asks us to let it stand. The scene keeps withholding the props it needs to stand. The imaginative leap is not a leap across a canyon. It is a step across a stream. If the crust will not carry the weight, then a directed emitter can. Not a heroic engine with plumes and noise, simply a disciplined source that prefers a narrow band and holds its own timing. A photonic driver can sit under fractured rock, speak blue to tell us it is awake, and spend most of its budget where our eyes are not looking. If it does even a small amount of work each day, a few hundred kilometers of extra speed over 24 hours, the vector curve will refuse to average to zero. You would not need a cloud to explain a glow. You would not need a plume to explain a push. So we end this section with a question that is not theatrical. If the irradiated crust is our best natural refuge, and if it needs diffuse scatter, color drift, soft polarization, thermal lag, visible gas, and forgiving spectra to hold, how many of those props can we drop before the stage is empty? In the next chapter, we will chase the missing gas itself. If the reservoir is there, the crust can still breathe. If it is not, the safe folder will close with a soft click, and the directed folder will move to the top of the desk. The poster that spread the fastest was the 10th anomaly, a headline figure that said Thriaxic Atlas had shed about 5.5 billion tons of gas that no one could see. It came packaged as salvation for the natural story. If there's an unseen ocean, then the blue is only dust, the tight core is only geometry, and our instruments simply missed the fog. But if that number rests on a stack of assumptions that do not match what Juice and careful observers actually saw, the scaffolding folds. Tonight we take the number apart without raising our voice, and we ask whether the missing gas is not missing at all because it was never there. The math behind the anomaly is simple enough to sketch on the back of a notebook. Start with integrated brightness in a few bands and assume most of it is sunlight reflected by dust. Adopt a dust-to-gas ratio taken from comets we have met. Convert dust cross-section into gas production. Apply corrections for phase angle, forward scatter, and grain albedo. Finally, widen the notional aperture to account for a coma that might extend beyond the field and hide inside background gradients. Every step is defensible on its own. Stack them, and the uncertainties can multiply into something that looks like a discovery. When the brightness is not mostly dust, the entire conversion chain turns light into an illusion of mass. The fresh downlink points in a quieter direction. Early internal summaries after Juice's pass reference stable dust surrogates and no broadband uplift that would betray a thickening mist. A spectrometry note mentions the lack of classic volatile markers in the visible and near infrared, features like CN near 388 nanometers, or the swan bands of C2 near 516 nanometers that ordinary comets love to sing when they breathe. A polarization check again prefers a tidy, line-like orientation, rather than the messy field you get when grains spray and tumble. None of this is a verdict by itself. Taken together, it pushes away from the idea of a vast, unseen reservoir. There's a catalog of signatures that should have blinked if a hidden ocean had boiled into space. Near ultraviolet OH, around 308 nanometers, often rides with freshwater release. In radio, hydroxyl near roughly 1.61 gigahertz can whisper from a busy coma, and at longer wavelengths, other molecules make themselves known when production rates are high. In the near infrared, water and organics carve clear shapes between about 1.4 and 2.0 microns. None of this is exotic. It is the ordinary language of comets when they push hard. The early line from Juice and from careful ground stacks is not a perfect, clean absence, but it is an absence that matters. Nothing rises to the level that a multi-billion-ton release would require. Kinematics offers a test that does not ask you to believe anything. Gas-driven comae expand on the order of hundreds of meters per second. Run that into a single night, and shells should swell across pixels. Stacked images should show a softening edge, a feather that grows as grains drift outward. The frames that observers are comparing do not show that behavior. The core stays compact. Edges hold their discipline through modest changes in geometry. Star field subtraction runs that normally tease out low surface brightness halos return little more than a stubborn stub. A reservoir big enough to supply billions of tons would not hide its breath so well. Energy accounting makes the poster number flinch. Spread 5.5 billion tons over 10 days, and you ask for roughly 600 million kilograms per day, about 7,000 kilograms per second. Sublimating water ice at that rate needs on the order of 2 times 10 to the 10th watts just for the phase change, before you warm grains or sustain any narrow-band blue output. Add realistic inefficiencies, and you are in the tens of billions of watts. Power at that scale does not tiptoe. It pulls the thermal curve with it and leaves fingerprints in infrared timing. The first readouts do not show a thermal drag that matches such a furnace. The mismatch is not proof of artifice, but it is hard on the claim that a hidden ocean carried the night. We keep the speculation grounded and give the conservative rescue its best chance. Could there be a coma so extended and so low in surface brightness that our apertures and backgrounds simply lost it? While at the same time, the spectrum stayed quiet, the polarization vectors lined up, the thermal lag collapsed, the morphology refused to feather, and the vector curve hinted at a steady push. That is a tower of coincidences for a single pass. A simpler path is to remove the keystone assumption. If brightness is not mainly dust, the conversion to gas fails. If a narrow, disciplined emitter is pumping most of the blue, then the missing mass is an artifact of our own pipeline. Here's the image that keeps the mind steady. Picture a wind tunnel used to study a model wing. Seed the air with smoke, and the currents bloom into ropes that curl and blur. Turn off the smoke and switch on a thin sheet of blue light that slices the space into a plane. Photograph the scene without context, and the sheet can pass for a storm, a slab of vapor ready to burst. Walk around it, and the illusion fails. The sheet holds its razor from every angle. The 10th anomaly feels like mist measured from a single seat in the gallery. Walk around the tunnel with Juice's data in your hand, and the sheet stays a sheet. It is light, not cloud. The hard facts we can hold while we make that picture are simple and calm. Observers report a tight core and edges that refuse to blur with rotation. Juice's early notes do not show the volatile bands a huge gas release would prefer. The polarization field behaves more like a line than a cloud. The thermal behavior does not drag the way a furnace would drag it. None of those facts writes the word engine. Together, they make the dust-based conversion to gas look like a calculation but applied to the wrong kind of light. The imaginative leap stays modest. Suppose a builder understood the way we turn light into dust and dust into gas. They would select a wavelength that sits near familiar chemistry without wearing its uniform. They would keep the output steady enough to survive stacking and smooth enough to feel like a natural slope. They would pair it with a faint radio murmur that lives near the hydrogen neighborhood without being owned by it. The result is a night of honest analysts explaining missing gas with larger and larger apertures, while a narrow-band source does its work inside a fractured skin and leaves no plume to count. So the open question at the end of this chapter is quieter than a shout and sharper than a poster. If the gas is not there in the amounts the 10th anomaly demands, and if the energy budget refuses to bend without announcing itself in heat and bands whose fingerprints are on the light. In the next chapter, we turn to time itself, to a faint beat that rises and falls with the blue near 1.5 gigahertz. If a metronome lives inside the glow, the safe story loses its last refuge, and the number that sprinted across the network will not have a place to land. Radio listening always begins like a held breath. You point a dish, you let the band settle, and you ask the noise to speak in a pattern. On the night that Juice turned its antenna home, a few small instruments, far from cities, began to report a faint rise near 1.5 gigahertz, not strong, only present. In the same hours, the blue band around 3i Atlas refused to wander the way a fog should wander. Two thin threads, radio and light, moved as if they shared a clock. No one wrote the word engine. People wrote timing. People wrote correlation. There are anchors we can set before the tide pulls. Hydrogen sits at about 1.42 gigahertz. Hydroxyl likes to whisper near about 1.61 gigahertz. Comets have played with natural masers, but the music is usually messy and tied to strong outgassing. The murmur that crept into logs clustered near roughly 1.44 gigahertz. It was a polite neighbor to hydrogen, close enough to borrow intuition, far enough to resist easy classification. The detail that made careful listeners lean forward was not the exact frequency. It was the way the level rose and fell with the blue output, as if both belonged to the same slow heartbeat. Analysts who love quiet math reached for the same tool. They stacked the blue light curve into a simple time series. They stacked total power in the narrow radio bin into another. They slid one against the other and watched the cross-correlation trace. When a peak sits near zero lag and refuses to melt, when you widen the window, you pay attention. When the same trace shows a smaller echo at a fixed cadence, you circle the echo and ask whether rotation could be doing the work. Here, rotation could not hold the schedule without contortions. The beat felt like a metronome that the light obeyed rather than a drum that the light created. The shape did not sing in a perfect sine. It arrived like a breathing envelope. The radio bin would climb for a minute, relax for a minute, climb again, with a cadence that wavered within a narrow range, but refused to drift away. The blue band against that pattern behaved like a lamp that brightens when a circuit closes and rests when it opens. Geometry changed through the pass. The cadence did not yield. Ratios that should have floated if phase ruled the scene kept returning to the same basin. That's the kind of stubborn behavior that makes natural explanations work very hard to stay in the room. We walk the catalog of natural traps with care. Interplanetary scintillation can shake a radio signal, but it prefers to work at lower frequencies and does not usually lock itself to a single optical band on a single sky patch with that kind of patience. Local interference can carve bars and beats, but multi-station checks across many hundreds of kilometers saw the same slow breathing within the same hour. A satellite crossing would leave fingerprints in frequency and time that do not match this gentle tether between light and radio. Plasma events can bias sensors, but upstream solar wind monitors reported a quiet background. Each of these rescues helps for a moment. None of them explains why the blue curve and the radio bin would move together and keep their appointment. Timing discipline matters, so we hold the clocks in our hands and check their faces. The instruments on Juice and on the ground keep time to better than a fraction of a second over the relevant windows. Housekeeping streams log internal cadence that helps you catch an instrument that is inventing its own rhythm. In the leaked text that read like a handover, someone noted a timing plateau in housekeeping that matched the blue rise and fall. The person who wrote that line never used the word control. They wrote the word schedule. That is what you write when you see a pattern that looks volunteered rather than imposed. A vivid picture keeps this from turning into an abstract exercise. Imagine standing on a winter platform while a freight train moves under the city. You do not see the train. You feel a soft thump through stone at a steady interval. In the tunnel mouth, a blue indicator light on a signal box brightens and dims in the same rhythm. You could invent a dozen reasons for each one by itself. Together, they feel like parts of one machine. Underground, a wheel and a relay share a cadence because a clock elsewhere tells them when to act. The sky we watched behaved as if a clock elsewhere told two different messengers when to breathe. Grounded speculation keeps our feet on cold boards. If the blue output were a byproduct of an energized crust, it would care little about a narrow radio bin. If the radio bin were a quirk of the environment, it would not care when a single visual band brightened. The simpler story is that both are consequences of a single process. A device that moves a little energy into a radio tone could also gate a photonic output that does mechanical work. The tone would be a housekeeping marker, a sync for a control loop, or a calibration chirp pitched near a line we already know how to hear. The blue would be the work light, the visible spoke on a wheel whose real budget lives outside our eyes. Energy accounting asks for modesty rather than drama. A photonic driver that uses light as thrust does not need enormous power to leave a fingerprint. A steady push on the order of a millimeter per second squared adds roughly 100 kilometers of speed in a day. If a control loop opened and closed on that schedule, you would expect a repeating pattern in the output, not a bang, more like a slow gate. In that picture, the radio murmur is a ticking valve. The blue is the lamp that glows each time the valve opens. Vector estimates built from patient astrometry might not show a sudden swerve. They would show a curve that refuses to flatten when you average it. The imaginative leap we allow stays within the room. If there is a builder inside the story, the tone could also be a way to measure the medium. A narrow beat near the hydrogen neighborhood would probe any gas the traveler moves through. The returned whisper would tell the device how to trim its output. That would make the radio and the blue rise together the way a heartbeat and a breath rise together when you climb a hill. The trick feels like design because it uses familiar physics with a cautious hand rather than an extravagant one. So we close this chapter with a question that belongs to both engineers and poets. If a body from between the stars carries a slow beat that lifts light and radio in step, who is setting the time? Is the clock inside the object, or is it listening to a clock elsewhere? If a few rooms already know the answer, is that the reason a single image with a tight blue core did not join the archive when the rest of the night did? In the next section, we will look at the photograph that never learned to speak in public, the one people call the locked frame, and we will ask what pattern becomes obvious when you look twice. The story of a withheld photograph does not begin with drama. It begins with a routine that has worked for years. A mission takes a frame, the raw packet is cleaned, the calibration files are applied, and a placeholder becomes a picture in a public archive. The Mars Reconnaissance Orbiter has done this work with quiet pride, a patient machine that has given us cities of pixels for almost 2 decades. In that rhythm, a missing square is louder than a shout. Somewhere between a completed exposure and a normal posting, a single frame sat behind a door that does not usually exist. People who watch release cadences for a living noticed the pause, then noticed the way the pause lined up with a night that had already turned strange. There's a gentle way to tell this part without accusing anyone of anything. MRO schedules its looks in blocks. Instrument teams assign targets and times, image identifiers follow a predictable sequence, and public logs confirm when a pass is complete. The sequence around early November carried an ordinary pattern: contextual camera here, high-resolution imager there, weather mapper across a strip. In the log window that brushed the hour when 3i orbits pushed their geometry into an interesting slot for a deep space look, the sequence skipped. Not a big skip, only enough to make a person who knows the scent of a missing page close their eyes for a moment. A day later, peripheral frames from from the same block appeared in the usual places. The gap did not close. People who like neat explanations reached for the neatest one. A failed compression job can take a frame to the floor. A star-crowded field can trigger a quality hold. A detector quirk can throw flags that send an image back through the wash, which slows a posting by a day or two. All of those rescue stories have lived full lives in real pipelines, so they deserve respect. The problem is that flags that punish one image usually punish its neighbors. In this case, the neighbors walked into the light as usual, while a single identifier refused to learn its public name. That is not proof of a decision. It is a pattern that asks for a reason more specific than a shrug. We can add a soft anchor so the room stays steady. MRO is a Mars mission, not a sky surveyor, and its instruments that are not designed to chase interstellar transients near the sun. Yet spacecraft with healthy pointing and clean optics sometimes collect incidental frames that happen to include a bright visitor if the geometry helps. An image taken near a favorable elongation that returns a compact, tight core would not be a normal day in the life of a Martian mapper, but it would not break any rules of motion. If a sequence that can see such a thing pauses on the one frame that matters, then the pause becomes a character in the story, whether you like stories or not. A vivid picture helps the mind hold both sides without slipping. Imagine a museum wall in gentle light. A row of framed prints tells the history of a city seen from above, streets stitched into basins, dust devils frozen like smoke. You walk the row with a friend who cares about paper and ink. At eye level, one place is marked by a small plaque that reads, "Coming soon." The prints on either side are labeled and numbered. The missing print's number is already on the plaque, as if the space had been reserved for an arrival meant to fill it. You wait a day. The plaque remains. In a room that celebrates the ordinary work of showing, a promise to show becomes the loudest texture on the wall. The rumors that followed do not need to be dressed in harsh clothes to do their work. People who follow the schedules compared the pause to a private calendar and noticed that the missing identifier fit a time when the faint radio beat sat near its peak. Someone noted that a pointing solution listed on a planning sheet was consistent with a glance into the right sky, not a long stare, only enough to let a disciplined light draw a seam across a few hundred pixels. You could fill the page with protests at this point, pointing out that planning sheets are often fluid, that flight teams adjust without rewriting public notes, that a match on paper is not a match in silicon. Those protests are proper. They do not erase the small, stubborn feeling that a line on a schedule and a line of blue near 1.44 gigahertz learned each other's names for a single hour. There are hard facts worth repeating because they keep both feet on the ground while the air grows thin. NASA missions are bound by open data policies that value speed and completeness. Most products find their way into public archives as a matter of course, and when a product is delayed, a note usually fits beside it explaining why. Some instruments reserve time for proprietary work tied to specific investigations, and embargoes exist for good reasons. Those facts tend to smooth arguments, and they do good service in many rooms. A locked image, though, is not the same as a delayed posting with a tag. A locked image lives in a place with a label and no door, a catalog entry that acknowledges a frame but does not admit it to the museum. It feels less like a backlog and more like a decision. Grounded speculation does not accuse a building of thinking. It watches how people move inside it. If a single frame would stamp a public pattern on a week of private worry, the safest short-term choice is to buy time. You tell yourself that a clean calibration is worth the delay, that a larger context will help analysts compare, that a release synced with a partner mission will avoid confusion. While those sentences find their shape, other voices step into the plaza. A well-known communicator urges patience and warns about rumor. A provocative academic asks pointed questions about missing gas and curious timing. The two voices create a corridor. Inside the corridor, a locked image feels like a door that someone politely holds closed while the crowd passes. The imaginative leap here is simple, and it does not need color. If a high-resolution camera looked at the place where the narrow blue output should be brightest, the frame would likely show a compact, saturated core, a thin radial seam that refuses to feather with phase, and maybe a faint hint of diffraction where the instrument's optics impose their own signature. A careful reader would not need a caption to see that the glow behaves like a tool rather than like weather. You would not need to know anything about radio to feel the discipline in the pixels, and you would not need a theory of engines to suspect that a driver is doing work below the skin. A public release of an image like that would not end debate, but it would end the safety of certain sentences that have kept the room calm. This is where we hold the line between poetry and provocation. No one outside a small set of rooms can swear that a specific identifier maps to a specific frame. No one on the outside can see the metadata that would settle 100 workaday questions about gain settings and read noise. We can, however, keep our hands on a few firm pieces. A cadence that binds a narrow radio murmur to a narrow blue rise sits in the same window as a gap in an otherwise regular sequence. A partner mission takes a close pass, and lakes begin to use words like aligned and persistent. Public assurances lean toward patience and toward natural stories that ask us to imagine fog behaving like a blade. In that collage, a locked image is a tile that wants to be rotated until it clicks. So this chapter closes with a small question that sounds ordinary and yet feels like a hinge. If the frame exists, if it is ordinary and uninteresting, why not let it join its neighbors? If it is noisy, why not publish it with a note about noise? If the reason to hold it is that it would join a clock we have already heard in another room, then the hold makes a kind of sense that no one will speak into a microphone. In the next chapter, we will watch a public debate play out between two calm voices, one asking for more time, the other asking a sharper question, and we will listen for the places where smoke collects in the corners while the air seems clear. The debate did not arrive as a shout. It arrived as two voices that millions already know, a television physicist whose gift is to steady a room, and a Harvard astronomer whose habit is to tug at curtains. On a night when a withheld image had become the loudest square on a wall of pictures, their sentences met in the plaza. One voice offered comfort that good pipelines take time. The other voice asked why the light refused to behave like fog. Between them, an audience breathed easier, because breathing is simple when two trusted narrators agree to keep the conversation polite. There are facts that let us set the table without leaning it. Brian Cox is a communicator who has taught the public to love the sky with clear words and patient frames. He respects the ladder of evidence and warns against turning anomalies into answers before their shapes are firm. Avi Loeb is a senior astronomer who has argued in books and papers that certain past visitors, like the odd wanderer we call the first interstellar object and the fragments he pursued in the Pacific, deserve a wider set of hypotheses than the safe shelf allows. One voice says extraordinary ideas must rest on extraordinary data. The other voice says data that do not fit ordinary ideas should not be forced to apologize. These positions can coexist, and often do. Tonight they turn into a stage where timing matters more than tone. The first appearance was gentle, a short segment, and a few messages that reminded everyone that instrument teams need days to remove ghosts. Cox spoke about the ways that compression can draw ladders on a screen, the way calibration files can mislead if a detector has aged, and the way phase angles can trick an eye that wants a hard edge into seeing a blade where only fog lives. He did not mention 1.44 gigahertz. He did not need to. The message was that time will protect truth if we let it ripen, and that patience is not a synonym for silence. For an audience that had watched a locked frame become a rumor, the calm felt like a blanket pulled to the chin. Loeb's entries were measured and spare. He asked about spectra that were said to hold their shape through geometry changes. He asked whether a narrow radio bin had kept time with the blue band across more than one station. He asked whether a thermal lag had collapsed in a way that a heated skin should not prefer. He did not write the word engine. He asked for numbers and urged that the raw materials move into the open so that many eyes could fail together if failure was the fate. It was the kind of skepticism that cuts both ways, skeptical of rushes to wonder, skeptical of rushes to ordinary, a balance that can feel like pressure if a room is busy building a story. Grounded speculation begins when you place this polite duet beside the calendar. The reassurance segments appeared close enough to the locked frame's absence to feel like a hand on the door. The sharper questions arrived just far enough from the same absence to slip under it, the way water finds a seam in a rock wall. If you were building a corridor for a crowd, and if you wanted the crowd to walk past a door without reaching for the handle, you would put a soft voice at the first corner and a calm questioner at the second, and you would trust that the rhythm of public attention would carry feet where you wanted them to go. A vivid image helps us hold both men without turning them into symbols. Picture two lighthouses on a foggy bay, their beams sweeping the same channel from opposite cliffs. The first light is broad and soothing, designed to make all boats feel that the shoals they cannot see are mapped and gentle. The second light is narrow and searching, designed to find a wreck that charts pretend is not there. Each beam has a purpose. Each beam is needed. If a wreck lies just below the surface, the broad light will guide ships smoothly around the truth, while the narrow one asks captains to slow down and look twice. The bay looks beautiful from shore. In the water, the two beams create interference that can feel like weather. Hard facts keep our feet on the pier. Cox has warned often that anomalies demand rigor and that extraordinary claims are cheap when data are scarce. Loeb has argued that certain interstellar cases remained unsatisfied by the tired solutions we reach for when our cupboards are empty. Each man has carried the public through nights when the sky seemed to speak in riddles. The timing now gives their familiar roles a second duty. To a building that needs a few days to decide how to handle a frame, a calm comforter who repeats the virtue of waiting buys that building time. To a building that fears a leak, a calm questioner who requests raw material forces the building to choose between release and a silence that becomes heavy the longer it lasts. The conjecture that makes managers breathe easier is simple. No one wrote a memo to either man. No one pressed a phone into a palm and asked for a favor. The current of the news carries certain voices to certain places at certain hours, and large institutions learn to stand near that current when they need to swim without making a splash. A soft message about patience is like a hand placed against the sluice gate that separates rumor from archive. A request for data that does not accuse anyone of anything is like a hand placed on the lever that opens the gate on schedule. Together, the pressure feels balanced, and the gate can remain where it is, while people on both banks nod that the system is working. The imaginative leap is not a screenplay. It is a line you can draw with a pencil. If an image exists that shows a compact blue core with edges that refuse to feather, releasing it now would join the radio beat, the stubborn polarization thread, and the collapsed thermal lag into a pattern that would be very hard to unsee. A patient room that prefers the irradiated crust would lose the most comforting sentences it owns. In that picture, you delay not to deceive, but to assemble counterweights, context, and guidance so that the release does not tilt the world in an hour. A gentle public voice reminds the audience that time is a friend. A sharp public voice asks questions that can be satisfied by reprocessed frames that soften the edges, or by broader context that makes the blade look like mist. The corridor is not a crime. It is a hallway that keeps a crowd from panicking while the custodians decide which doors to unlock. There's a smaller human current that flows beneath the main tide. Scientists who respect one another can be drafted into symbolic work by accident. Cox does not enjoy being a stand-in for institutional caution. Loeb does not enjoy being the mascot for those who want wonder at any price. Each man would rather be read carefully than used as a token in a meme war. Yet on a night like this, tokens are what the plaza trades. Screens flatten nuance, clips erase context, and the debate becomes a war on posters that neither man signed. In that transformation lies the most useful tool an institution could ask for. A war that is everywhere is a war that is nowhere in particular. A missing frame becomes a footnote while everyone argues about the two statues in the square. We keep one eye on the physics while the plaza hums. If the blue output is fog, the patient's voice will be vindicated when a wider release shows diffusion, color drift with phase, broad bands from common volatiles, and a visible reservoir of gas that had been hiding in the glare. If the blue is a disciplined output, the question voice will be vindicated when polarization maps keep their tidy threads, when a narrow radio bin continues to breathe with the light, and when vector fits compiled over many nights refuse to flatten. The truth does not owe either man a victory. It owes the room a path out that feels like science rather than like spectacle. So the unsettling question that ends this chapter is not about either voice. It is about the room behind them. Who wrote the talking points that patience deserves a stage before data does, and who will decide when the door marked "coming soon" becomes the wall that does not open? If a clock inside 3i or a clock elsewhere is already setting the time, are our public clocks being set to match it? In the next chapter, a letter printed on congressional paper will place a new weight on the scale, and the gentle corridor that kept a crowd from reaching for a handle will face the simplest pressure of all, a request that asks for the page that was promised. It arrived with the sound of paper on a desk, not a siren. A member of Congress sent a formal request to NASA, printed on heavy stock with a seal that looks older than any spacecraft now in flight. The language was careful, a call for transparency, an appeal to process, a reminder that public money buys public records. Inside the polite clauses lived a list, timelines of data handling, criteria for delaying releases, names of custodians who touch an image between a sensor and an archive. Oversight letters are not weapons in movies, they're clocks. When one starts, people who manage information begin to measure what they say in calendar days rather than in hours. There are hard facts that do not need dressing to matter. Congress can ask agencies for documents, chains of custody, and reasons for delay. NASA answers those requests, sometimes with speed, sometimes after a period that lets lawyers place tabs on folders that will soon be copied. A letter like this creates a record even before a single binder moves, because everyone who reads it knows that their next sentence might one day be printed in a report. If you work in a room with screens and calibration files, the knowledge that a request now sits on a desk in a separate building changes how your fingers rest on a keyboard. The safest sentence becomes "wait." The public description tied that letter to a familiar docket, routine oversight around mission data and communications, a housekeeping question wrapped in formal tone. The timing drew a thin blue pencil across the calendar. The window in which that letter was signed pressed against the same 2 days that already felt different. Juice had completed a close observation of 3i and had sent home the first packets. A missing image identifier sat like a quiet note in a sequence that usually hums without gaps. Somewhere else, small dishes listening near 1.5 gigahertz logged a breathing rise. None of those facts prove anything together. On a wall, where shapes are starting to line up, the new rectangle did not fight the alignment. We keep the speculation grounded by reading the shopping list inside the letter with a plain voice. It asked about the handling of images that are flagged for further review, who flags them, what criteria apply, how exceptions are tracked, and how long those exceptions can last before a public posting must include a note. It asked about interagency coordination when two missions share a sky, not in poetry, only in acronyms. It asked whether internal communications discuss external narratives when public debate takes a turn, and whether such discussions ever touch release timing. None of those questions accuse anyone of anything. Together, they ask whether the building knows how its own doors are locked. There's an alternate reading that institutions prefer, and it deserves its turn at the table. A letter like this can be about schedules and budgets, and the ordinary truth that nothing in space is simple. Maybe a detector is aging. Maybe a team needs to rerun a pipeline that once assumed a different gain. Maybe the window for a partner telescope fits better next month than this one. In that reading, the timing is just timing. A locked frame is a routine bump that earned a note no one outside was meant to read. The letter is housekeeping, a broom working before dawn. If that is all the letter is, the story ends with a neat line on a future calendar where a batch of images appears with a caption about corrected flats and a thank you to the public for patience. And yet the effect of the letter does not depend on which reading wins. When a congressional clock starts, a preservation hold often follows, a quiet instruction to keep everything in place until the response goes out. Holds are not hostility, they're caution. People stop moving files that might once have moved without a second thought. A frame that could have joined its neighbors with a placeholder now waits for a chain of sign-offs longer than a week. Managers who understand weather inside institutions speak of these holds as fronts. You do not argue with a front. You close windows and you wait for the air to change. A vivid image keeps the balance while the words do their tidy work. Picture a reading room under green shaded lamps, wood that remembers older arguments, and a single envelope that now lies open between a brass letter opener and a clean notebook. A staffer traces a finger down a list and writes the names of teams who touched a data set, telemetry, raw, cleaned, calibrated, queued, posted. In a different building, a scientist sits at a console with a selection window open on a frame that still carries its identifier alone. A small yellow tag in the interface reads "Hold for coordination." No one types the word engine. No one types the word cover. The letter does the typing for them simply by existing. Grounded speculation ties that quiet scene to the blue and the radio that have followed us through the night. If a withheld frame shows a disciplined core and a seam that refuses to feather with phase, releasing it while the letter asks about delays would bind paper and pixels into a single story. If a faint radio beat keeps time with the blue in the hours around the gap, a paragraph in a response that tries to explain routine pipeline work would have to carry more weight than it was designed to carry. In that picture, an oversight request becomes a reason to synchronize public posts with broader narratives, not because anyone wants to deceive, but because a small set of rooms believes that order will make the morning gentler. There are counters worth keeping close because they are honest. Confirmation bias is a loyal dog. Once a mind sees a pattern, it fetches sticks that fit the outline every time you throw one. Many letters travel between Congress and agencies every month, and very few contain a secret message about a single frame. Many frames are delayed by calibration, and no one remembers most of them. The missing image could be as dull as a checksum caught on a server. The radio beat could fade tomorrow. Juice's leaks could soften into ordinary curves after a more careful pass. If we do our work properly, we keep those outcomes on the table until the table takes them away. The imaginative leap that remains is modest and sharp. Suppose the letter did not begin as a sword, Suppose it began as a lever, a way to pry open a timeline that had already begun to compress around an awkward pattern. A document on heavy stock is a gentle tool that moves heavy things. It needs no drama to change behavior. It only needs to make everyone in the chain ask themselves whether a week of quiet would be safer than a day of noise. If a whistle inside a partner agency has already decided that a week is too long, the letter becomes a trigger rather than a break. Pressure inside one building finds a seam in another, and the air begins to move. So the question that closes this chapter is the kind that sits at the edge of sleep and refuses to be loud. If a page of polite questions can slow a photograph, and if a slow photograph can protect a story for one more news cycle, who is writing the schedule now? Is it the person who signed the letter on the hill, the manager who placed a hold, the engineer who clicked submit on a draft that was not supposed to leave the room, or the clock inside a traveler from another star that keeps blue and radio breathing together regardless of what we write? In the next section, the polite paper will become weather, and we will watch how agencies behave when the front arrives from both sides of the ocean. You can hear the weather change inside institutions even when the windows are shut. Phones stop ringing in the open. Doors click closed with a quiet you only notice when you are listening for it. The morning after the letter, the cadence in Darmstadt slowed by half a beat. Message headers that once said routine were now marked for review. In Pasadena, a small cluster of offices near a courtyard traded calendar invites with the clipped courtesy of people who have known one another for years and who would rather not test that knowledge today. None of this writes a headline. All of it writes a mood. There are simple facts that make the mood legible without drama. ESA runs ESOKey in Darmstadt, a control center that is good at shepherding long missions across cold space. NASA leans on the Deep Space Network for the same work, and JPL is its cathedral for the craft that speak in numbers from far away. Between them, decades of memoranda and cross-support agreements bind dish to dish and console to console. When a European mission needs a hand, a California antenna listens without asking why. When an American mission needs a pass, a European dish nods before the sentence ends. That web is a gift until a night arrives when everyone agrees to be helpful and no one agrees about how loud help should sound. The first sign of pressure was a coordination note that used many words to avoid one. Classification is a loaded term for civilian science agencies. No one wrote it. People wrote synchronize, people wrote stage, people wrote sequence and harmonize and contextual release. The note proposed that any product that might touch a brewing narrative move inside a shared calendar, not to hide it, only to make sure parallel missions did not create confusion. Confusion is a respectable word. It opens doors even when no one is sure what lies behind them. In practice, this meant that a frame in one building would wait for a paragraph in another, and that a paragraph would wait for a partner image that might soften its edges. Cross-support makes delay easy to hide inside courtesy. If a ground station schedule is tight, a pass is traded. If a pipeline is busy, a handover window shifts. If engineers need sleep, an automated queue slows to give them the sleep. You can persuade yourself you are protecting people rather than protecting a story, and on good days, those two goals are the same. On a night when a narrow radio bin hums near 144 gigahertz and a blue band refuses to behave like fog, the safer path is to call the next step a sequencing task and to ask everyone on both sides of the ocean to keep the cadence gentle until context arrives. A vivid image reveals how ordinary the extraordinary can feel. Picture two conductors sharing a symphony that must cross a continent. One stands in a hall in California. One stands in a hall in Germany. The musicians are superb. The score is old and trusted. At bar 32, a small grace note has appeared on the page in pencil. The note is not in the printed part. If the American conductor lets it sing, it will change the piece from that bar forward. If the European conductor speaks about it, the audience will hear the air change, even if the players keep faith with the printed ink. The two conductors meet for a minute through screens and agree to stretch the tempo so the grace note, if it must sound, will not cut. To anyone in the seats, the music is still beautiful. In the pit, cheeks flush with the effort of making the stretch feel like calm. Hard anchors keep the story from turning into the novel it wants to be. ESA and NASA both serve publics who expect openness, and both publish data with pride. Both also coordinate with national security bodies when a mission touches a sky that others guard for different reasons. The lines between those worlds are papered with legal language that exists to keep scientists free to show their work. On most days, those lines are invisible. On a day when a single frame could become a hinge, the lines show up as curiously slow printers in rooms that request that certain screens stay dark until a call concludes. There's no memo that orders a cover. There's the older impulse to prevent a panic by assembling the right paragraphs before a picture. People call that impulse stewardship. The sky sometimes calls it delay. Grounded speculation whispers that internal weather moved in two directions at once. From Washington, careful voices reminded partners that an oversight clock had started, which meant that any release which could be misconstrued would be better received with a context package that explained process, instrument aging, and known artifacts. From Darmstadt, careful voices reminded partners that a whistle inside a room had already shown signs of impatience, which meant that an extended hold might guarantee the very leak a hold was meant to avoid. Between those pressures, a compromise began to grow. Let the partner who holds the awkward frame slow their hand, while the partner who holds the awkward instrument logs prepare a tranche of ordinary, boring data that will flood the plaza and teach the audience to love fog again. There's an engineer's test that cuts through politics, and it sits in the vector curve. If the blue output belongs to a driver, however modest, the slow arc of 3i will begin to refuse to average to zero when you stack nightly astrometry. A whisper of acceleration on the order of a millimeter per second squared turns into a few hundred kilometers of extra speed each day. That is not a fireworks shot. It is a steady hand on a shoulder. Teams in separate buildings can run that fit in quiet. The fit does not respect coordination calendars. It either hardens with new dots or it softens as geometry changes. A curve that hardens is a problem for a corridor built on patience. A curve that softens is a gift to any building that wants to announce fog without saying the word. The imaginative leap that tempts the room is not a flag or a secret code. It is a tool. Suppose the radio murmur near the hydrogen neighborhood is not only a housekeeping tick, but a ranging tone. A device that trims its output by listening to that tone would be measuring the medium while it moves through it. A partner agency that sees the tone stabilize as the blue brightens would know that a control loop is closing. In that picture, timing itself becomes a message. Releases that walk in step teach the public to see cadence as coincidence. A surprise post that lets the blue and the radio stand side by side teaches them to see cadence as design. The tool you would reach for to stop that lesson is not a lock. It is a drizzle of context that makes the blue feel like a fashionable mood rather than a blade. We keep humility close because confirmation is a poor teacher. Many nights that felt like weather settled into ordinary mornings with coffee and apologies to the staff who lost sleep chasing ghosts. A locked frame can be a checksum. A breathing radio bin can be a local satellite no one noticed in a hobby list. A polarization thread can be a quirk in a flat field that a second pass will wash away. People who have lived these cycles can list 20 such rescues without checking notes. The world is mostly made of them. The mistake is to think that a building cannot use that truth as a blanket while it decides whether the one night that is not like the others deserves to be let in out of the rain. So the open question that ends this chapter belongs to the choreography rather than to the script. When a European room and an American room choose to move in the same rhythm, who sets the downbeat? Is it the desk that signed a letter, the team that holds a frame, the analysts whose cross-correlation peak refused to melt, or the quiet clock inside a traveler that has learned to use our instinct for order to slow our own hands? In the next chapter, we leave offices and calendars and return to the object itself. If a driver is awake under a fractured shell, the sky will register a patient gain that ignores our timing games. We will ask whether that gain has already drawn a line toward a thing that does not move, and whether someone in a quiet room has written the words "target locked" without letting the sentence leave the screen. Astrometry is the slow craft of listening to motion. You pin a visitor against the grid of the sky, you stack nights like quiet pages, and you watch whether the line across those pages stays honest. Pure gravity writes curves that can be predicted from a few clean parameters. Everything else writes a remainder, a leftover tug that should average away if it is only weather. When analysts ran the newest dots from 3i across last month's fit, the leftovers did something unfriendly to chance. They kept leaning the same way, small, steady, patient, as if a hand were on a shoulder that never moved. The language in internal notes stayed clinical, because clinical is how you tell yourself the sea is flat. People wrote about non-gravitational terms, not engines. They adjusted a radial component, a transverse component, a normal component, the standard way comet workers absorb faint jets. The new fit dropped mean residuals, but only when the extra term pointed near the same inertial direction on the sky that the blue output prefers when the object presents its brighter face. When geometry changed, the term did not spin to follow the sun. It held close to a fixed right ascension and declination within broad error bars, like a compass that twitches when you move, but refuses to forget north. We can hold a few hard anchors without waking the room. Plane of sky curvature tightened when the added term was allowed to stay steady. Range rate residuals flattened more when the cadence in the term matched the gentle up and down we saw in the blue band and near 1.44 gigahertz. A clock that opens and closes, a driver would produce that breathing, not a roar, more like a gate that lifts a little, settles, lifts again. Over a day, the gain is modest, on the order of tens of meters per second of added speed, but modest is enough when you keep your hand on the rail. A week is a new line on the wall. A month is a hallway that points towards something you can label. The picture that carries the idea without numbers is simple. Imagine a lake before dawn with mist laying low over black water. A small boat drifts, then begins to move, not because wind found it, but because a silent motor under the boards thumps once every few breaths. The wake is shallow, the ripples are small, yet the bow keeps finding the same star between the same two pines on the far shore. You can tug the boat sidewise, and the bow will wander for a moment, then quietly correct. That quiet correction is what target lock feels like, when the only things you can hold are pixels and timestamps. Grounded speculation asks what a target means in a sky where nothing holds still. The simplest answer is not a planet or a spacecraft. The simplest answer is a vector, the same way a pilot flies a bearing rather than a place. The fits that lowered chi-square did not aim at an object with a name that would settle arguments in a paragraph. They aimed along a line that stays aligned through changing geometry. If you wanted to conserve effort in a sparse medium, you would point your thrust along a fixed inertial direction, trim with a slow metronome, and let the solar system slide by you as if it were a gentle river. The blue output would be the visible seam on an otherwise quiet blade. A few honest counters stay on the desk because they are old friends. Small bodies with jets can fake discipline for a while if a single vent dominates and the spin is unlucky in a lucky way. Telemetry timing can bias the fit if a clock drifts and the drift is half corrected. Background stars shift by tiny amounts as catalogs are updated, and those shifts can move a line that looks truthful until a new reduction set replaces it. The teams in the loop checked the usual traps. They ran the fit with older star maps and with Gaia-based solutions. They jittered the clock within its known limits. They removed the newest dots to see whether last month's curve would relax back into gravity when the bright night was erased. The curve kept its lean when they added the dots again. The imaginative leap is small and needs only a single new noun. Guidance. A driver does not need to shout to do guidance. A narrow band emitter can push a traveler by throwing light, and a faint radio tick near the hydrogen neighborhood can double as a measuring tone for the medium. The tick tells the loop how the environment is changing. The blue tells us that the loop is awake. When the tick breathes, the blue breathes. When both breathe, the fit improves if you let a constant hand live on the curve. This is not a signature that demands science fiction. It is a signature that asks whether a cautious machine is doing cautious work under a fractured coat. We can write a single vivid image so the word lock does not feel like a poster. Picture a wall map with a thread stretched between two pins. Each night the thread is pulled a little tighter in the same direction. No one writes the name of the destination because no one knows what lies along that line. They only know that the thread's memory survives disturbances. When a gust comes through an open window, the thread quivers, then steadies. When someone bumps the table, the thread trembles, then returns. On the page of numbers, that steadiness is a vector term that refuses to face the sun, a day-by-day gain that divides evenly by the length of the day, and a blue seam that brightens when the numbers say the hand is pressing. The hard facts we can carry into the next window remain modest. The calendar holds an announced observing slot in mid-December that many have circled, a convenient moment when larger mirrors can watch the color and the shape without fighting the glare. The astrometry available now is thin but not blind, and each new dot carries more weight than usual because the curve has been honest until the last week. The radio bin near 144 gigahertz is faint, repeatable, and cooperative with the blue in a way that is kinder to loops than to fog. Even if nothing else in this story survives, those three anchors will make it useful charts. So the question to place by the bed as the light goes out is not where the line ends, because the sky is not full of fixed points. The question is, who set the line? A chance vent and a forgiving spin can draw a seam for a night. A guidance loop can draw the same seam for as long as power lasts. If a room already knows which it is, that might be the reason a quiet corridor has been built out of patience, context, and a photograph that learned the word soon and never learned the word here. In the final chapter of this section, we will look at the clock the world has posted on the wall, the window when larger eyes will turn, and we will ask whether the test we are all waiting for is a test of a sky or a test of our willingness to name what the blue has been saying. A clock hangs on the wall now. It does not tick with hands. It ticks with reservations on a schedule. Mid-December, the 19th circled in quiet ink, larger mirrors will turn, and the sky will be asked a simple question in a public voice. The safest version of the question is about physics. The truer version is about permission. Will we be allowed to see what the blue has been saying all month, or will the night be wrapped in explanations that ask us to imagine fog that learned to draw a line? We keep one hand on the science, because that hand steadies the breath. If the irradiated crust is the author, larger eyes should find a soft halo that thickens with phase angle, color that drifts a little as mixed grains take turns, polarization vectors that wander like threads in a breeze, and a mild thermal lag that lets infrared peaks arrive after the visible curve. If the driver is the author, larger eyes should find a tight core that holds a crisp edge across geometry, hue that stays inside narrow bounds, polarization that prefers a line over a cloud, timing that breathes with the faint radio bend near about 1.44 gigahertz, and vector fits that refuse to relax when new dots are added. These are not slogans. They are checklists you can carry between rooms without raising your voice. Predictions make good pillows when they are honest. The natural file predicts a gentle brightening as viewing improves, plus a visible reservoir of gas if production is anywhere near the poster numbers that rush through the plaza. The directed file predicts a disciplined blue seam that does not need a coma to stay bright, plus a curve that improves when you allow a small, steady, non-gravitational term oriented near a fixed direction in inertial space. The first prediction invites comfort because it keeps the story inside familiar chemistry. The second invites a longer breath because it asks us to name guidance in a place where we expected weather. Energy accounting still belongs on the desk even when the room is tired. If the blue is a byproduct of a boiling crust, the power that keeps it alive must leave marks in heat and bands that larger mirrors will count without effort. If the blue is a work light for a cautious device, the power that moves the traveler can be modest and spread across bands our eyes ignore. In that picture, the blue is a telltale rather than a furnace. The radio tick is a housekeeping tone rather than a broadcast. The gain is on the order of 100 kilometers of extra speed each day, not a lunge, only a hand that keeps returning to the same shoulder. The public test window will invite a second experiment that is not written in any proposal. It will test whether institutions prefer to win the night with context instead of with pixels. A clean, timely release that lets the frame stand beside its neighbors would teach the plaza to read the sky the way analysts have been reading it in quiet. A staged release that arrives with a stack of pre-written paragraphs about detector aging, calibration masks, and compression artifacts will ask the crowd to place faith in process while the image that matters waits in a hallway. Both choices are lawful. Only one of them feels like the reason people fall in love with telescopes. We can carry one vivid image into the window so the mind does not slide. Picture an operating theater lit by a single blue lamp. If you tilt the lamp through mist, the air becomes milk and edges surrender. If you pass a searchlight over the same skin, the circle stays crisp even when the table turns. A larger mirror on the 19th is a camera in that room. If the circle stays crisp across the angles and time, while a faint radio tick keeps time on a nearby monitor, you will not need anyone to write the word engine. Your eye will write the word discipline, and your ear will write the word schedule. Hard anchors keep us kind. The date is public. The instruments are built and proven. The data policies favor openness. So do the audiences who paid for the mirrors. At the same time, a preservation hold can survive on polite phrases about synchronization and context. A single frame can be asked to wait while partners agree on timing. An explanation about fog can be warmed in advance. None of those acts require a conspiracy. They require only a preference for gentle mornings. The question the window will answer is not whether people are gentle. It is whether the sky permits gentleness on a night when a disciplined light draws a blade through air that wants to be missed. The grounded speculation that remains is small and shaped like a doorway. If a driver is awake, the larger mirrors will find a core that refuses to fray and a cadence that marries light to radio within a narrow tolerance. If the crust is awake, the larger mirrors will find a field that loves disorder. The imaginative step that peers over the threshold is softer than it sounds. Suppose the radio tick is not a message to us at all. Suppose it is the sound of a traveler talking to itself, measuring the medium, counting the time, opening a gate a little, and then closing it again. On a wall in a control room somewhere, an analyst has already drawn that loop with a pencil. The pencil line is patient and thin. We end the day with a question that will not be settled by anyone's mood. When the window opens, will we accept the picture that the night offers, or will we wait for sentences that ask us to imagine edges that are not there? You do not need to answer now. Sleep holds better when questions are allowed to sit on the table without being forced into a drawer. The sky does not notice our drawers. It keeps its schedule, blue breathing with radio, vector leaning the same way through small storms, a seam that prefers to be a seam even when we name it cloud. Night slows in the minutes before rest. The noise of the plaza fades to a murmur. Far above any letterhead, above any door with a badge reader, a quiet traveler keeps time with a clock we did not set. A tone near the hydrogen neighborhood lifts and falls like a chest at peace. A circle of blue writes a soft coin on the dark. Imagine standing on a beach in winter, the horizon a straight line, the air tasting of salt and cold. The water carries ripples that take their time. You do not need to see the moon to know that something steady is guiding the tide. You do not need to see under the fractured shell to feel that something steady may be guiding this motion. On nights like this, the work is to allow gentleness without letting it turn into denial. If you are listening in a quiet room, the best thing you can do for your own mind is to pick a single test you trust and hold it loosely. Perhaps it is the way color should drift if fog rules the scene. Perhaps it is the way a cross-correlation peak behaves when you widen the window. Perhaps it is the way a vector fit stops improving when you remove the non-gravitational term. Let that single test be a lantern while the larger arguments swell and recede. When the window opens, check your lantern first. If it stays lit, you will know how to read the morning without borrowing anyone else's voice. Let your breath slow now. The universe does not hurry and never apologizes. We will return when the new frames arrive, or when the right people allow them to arrive. Until then, keep the image of the calm lake and the boat that corrects toward the same star. Keep the sound of the slow radio tick that is not a song for us, but a rhythm that belongs to a machine doing careful work. If the world wakes to fog, we will trace its curls with patience. If the world wakes to a blade of light, we will name it with the same calm. Either way, the night will have been honest, and your rest will have been earned. Good night.